What's up, YouTube? It is Jason, and I'm gonna do a little special video. I'm gonna try something out. So obviously you might be able to see that I am actually on the road. Right now I'm kind of in the middle of nowhere, Texas, and had a couple of questions that have been coming up on about encoders on the YouTube channel in the comments. And one of them, I'm like, okay, this is something that I think that everybody should know. I wanted to try out to do something on the road. And so I've got a little recording setup here in my travel van, and I'm gonna try this. So we're gonna talk real quick about a couple of different ways to bring in an encoder signal into your project. If you're wanting an encoder signal, a speed signal in your PLC project, I had a user that asked basically, what's going on there? How do you do that? Well, first of all, I want to talk about a couple of different types of ways that you can get the speed and potentially the position out of devices. So one, the speed signal. If you just want the speed and you have an analog input, you can use what is called a tachometer, and that varies a voltage based on the speed. And so those are, a lot of times it's pretty old technology because it is not very accurate, but you can bring that into an analog input and then just use that analog input signal and kind of modify it in order to get a speed. Now, you would be able to also use that on a technology object, and I'll show you kind of what that is here in a second. Now, most of the time, you're not going to use a tachometer. Tachometers are pretty rough. They're not really suitable for speed control, really. I mean, it's just rough. Like if you're wanting the speed of a fan or something, sure, you could use it. But what you would normally want to do is either use an incremental encoder or an absolute encoder. So I'm going to talk about ways to, the first, an incremental encoder. The basics about an incremental encoder is that you have pulses that as the rotor turns, or as the encoder sits there and turns, it pulses. And so you'll have a pulse, and if you look at it on like an oscilloscope, you'll see kind of this square, hopefully it's square, pulse, and you'll get a single pulse like this. Well, most modern encoders are what is called quadrature encoders, meaning that it's not just one pulse, but it's two pulses at least. Sometimes it's a four pole. But on an A-B track encoder, you have A and B pulses on two separate series of lines. And with a quadrature, which would be an offset, and I'll show you this here in a second, those will be offset by 50%. And the reason you would do this is because that way, if pulse A comes first and then followed by pulse B, you know that it's turning in one direction. If pulse B pulses first and then pulse A pulses, you know it's going the opposite direction. So that is an incremental encoder, and those are based on pulses. The second type of encoders are absolute encoders, and they send over signals as an actual value. So they will send a position value. So on absolute encoders, you're always going to need some sort of interface or telegram or something. Your PLC may have pulse inputs to where it can evaluate a pulse encoder, but I'm going to show you how that we can do this in a 1500 PLC, and let's flip over to Portal real quick and see what this looks like. I have got a Portal project, and it's actually going to be for our next live stream, so this is a little bit of a sneak peek if you didn't know. But what I've got is our kind of test setup for our project that has a 1500 PLC, a remote rack, and a drive, and I've brought in an external encoder. I'm going to talk about that in a second. If you want to add in a incremental encoder, you are going to need to use this module here called a TM pause input 1. So TM pause input 1, and that is available You can find that up. So technology modules, and then position detection, TM pos input, and there's an older version and a newer version. I can't remember which one I have here. It looks like it is a newer version. So this is a newer version, and I actually have this set up in my lab, and it has a little hand wheel that a hand wheel is essentially a pulse encoder. And the way that you set this module up is you go in and you generally, say this, operation mode, module parameters, here they are. So you have either A, B tracks that are phase shifted because these are going to be 4 wires and there's going to be A and B, just like we talked about before. A, B, they're phase shifted. You can have redundant tracks, an A, B, and a neutral, or like a 0 pulse, so it knows when it hits the 0 pulse. You can have a pulse and direction, which are another type of encoder, just a single pulse, a counting up, counting down pulse, those sorts of things. If it's a counting signal, this TM pos input can be a counter. Anyway, but most of what you are going to use is going to be this AB phase shifted, because that's going to be your standard 2-signal quadrature encoder input. So you're going to wire those up, and I'm not going to change anything here. And there's a couple of different options that you'll have to figure out and like play around with in order to actually get your pulses set up to whether it's a 1024 or a 2048 or 4096, whatever it would be, depending on how accurate your encoder is, that's what you're going to be setting up here. Then that is going to bring in essentially you're going to get a speed, and I can't remember which one these are, but for this one, depending on how you set it up, the operating mode, I have this set up as a operating mode for a technology object. So it is going to condition it so that the technology object knows what it can do with it. And that's how most of the stuff on this channel is. All sorts of technology objects. And that's what I have over here. You can see that I have this hand wheel, and it is actually an external encoder technology object type. And what it does is it will provide something that you can link to. So you can synchronize to this external encoder. It gives you position data. It gives you everything that you need and stuff that's just like real easy to access. So you can see actual position, actual velocity, actual acceleration. All of those are just available to you to use. And I realize that I'm clicking on things that's probably behind my head right now. But just know that if you use a technology object, then it parses everything out and gives you the actual position and actual acceleration. And in order to work with that technology object, you're going to use all of the same MC functions that the rest of the channel works on. So that is kind of the easiest way, I guess, for a incremental encoder to be brought in as a technology object for some external system. One thing as well on this is the last one on here is this absolute SSI encoder. Now, this is, SSI stands for synchronous serial, I can't remember what SSI, but it's an actual encoder, and it is using a telegram of its own inside a packet that gives the position information. Remember, I said an absolute encoder is always going to give you the position in some way. An SSI encoder has its own little industry standard protocol that it uses, and you have to have some module to interpret that data so it comes out as a position. If this were input as an absolute encoder, the memory areas what is in the memory areas associated with this technology or the module would change, and one of them would be the position, and one of them I think is the velocity. But you can kind of go through those depending on what is actually sets up that. But just know that if you want to bring in an SSI encoder, which is an absolute encoder, you still need to use this TM pos input 1. Yeah, so that's those. Incremental and SSI absolute encoders are going to come in on this TM pos input 1. So the next, there's really a second type of absolute encoder that is kind of an industry standard, and it is called an NDAT. And I'm not really going to talk too much about those because there's, as far as I'm aware, if comment if you're watching this, if there is a module that I'm just unaware of that you could bring in. But as far as I'm aware of, the only module that I know that can bring in an NDAT encoder is the SMC or an SME. I believe it's a 20 and a 30 encoder, an SMC20 and an SMC30, and that's part of the S120 system. So if you want to bring in one of those, there's a way that you technically don't have to have an actual module out there, so like a motor module and a motor. If you're just wanting to bring in an external encoder, there is a way to do that. It's not really straightforward. You have to kind of set up a dummy axis and then assign it to the SMC30, but I might explain how to do that, but that's something that I need to do, like, honestly, on a live stream, because that sort of thing is a little bit more complicated. But that's only for an NDAT encoder. So the final type of encoder that you might run across is what you see here. Is honestly, there are a couple of different types of Profinet enabled encoders, and built into the catalog, which I have open, there's two. There's a Siemens version and a SICK version, and they're just a multi-turn or a single turn absolute encoders, and it's a Profinet. And what happens when you bring in these GSD files? By the way, there's other ones of these available. I think Encoder Products has a Profinet one available, but you would just have to manually import the GSD file into your TIA Portal project. But you would do what I'm about to do here. So what you would do is, once you've brought that GSD file in and you've gone and you can assign, I want to assign this to this PNIE1 subnet. It's going to link this up. It's going to give it the IP address. It's going to give it a memory area on the tCPU that I have here. And then I want to go to device view. And in device view, your hardware catalog will change. And the user that was asking me about on kind of what you need in order to bring in Profinet information, you do need a telegram. And there's telegram 81, 82, 83, 84, and then apparently a Siemens telegram 860. So anytime that you see a number over 100, that is a Siemens specific telegram. Anything under 100 is going to be an industry standard telegram by those definitions. So it looks like what we have here is 4 different types of industry standard telegrams: 81, 82, 83, 84. And there's the call out for these is probably in the S120 documentation. I've linked that in other places, but you can look up Telegram 81 definition, and Google will probably be able to find you something there. If not, leave a comment below, and I'll try to link something in our Google Drive. So, yeah, and by the way, if you didn't know, I put a lot of documents up and available for our membership. The lowest tier level, I think, is like $2 a month or something for a membership, and that gets you access to all of the documents. The higher level program stuff, the programmer level, that's, I think, like $5, and that gives you access to the live stream archives. And so when I actually do this Modbus archive, the members would actually get this archive to play around with. But just know that if I send up any documents, that's where it's going to be. It's going to be in that lower level, that $2 level, membership. And you can go in if you want to support the channel that way. But also just be like, hey, if it's a hardship or something, like, I can probably give it to you if you hit it up in the Discord. That's another way. If you sign up in the Discord, most of that stuff, like the documents and things, get put into the Discord as well. So anyway, you assign this a telegram. I'm just going to do an industry standard telegram. When I select the telegram, By the way, it's under submodules. So I go over to the device view of this encoder, and under submodules in the hardware catalog. Remember, the hardware catalog used to be like encoders and modules and all this stuff. Now we're in the device view, and this is the hardware catalog just for that device. And you can see under submodules, we have these telegrams. And so if I want a telegram 180, which is 2 control words and then 6 return words, then I would just take this, drag into that, and now that telegram would be available for use in anywhere really. Now it has a memory space that is available that will be associated with the telegram. Now, the easiest way that you would want to use this information would be on a technology object. That's the easiest way to do it. You don't have to mess around with anything, but the way that you would go through and do that is connected to a technology object. And so if you aren't able to use a technology object, then you still have that data. You don't have to use a technology object. I'll show you real quick how the technology object would get connected. I'm just going to look at this real axis, and I'm going to go into the configuration. And underneath the actual values here, there is the data exchange with the drive, which is one thing with the drive. That's like a Telegram 352, Telegram 105, Telegram 1, 2, whatever. And then you have the data exchange with the encoder. Now, you see that this, the way that I have it set up is it is actually pulling the telegram information, the encoder information from the standard telegram that I was using. So in this, the drive was using a standard telegram 3, and then here I'm saying encoder telegram, all right, I'm using my telegram 3, but I don't have to. I can go through and actually select, well, maybe not, maybe not for this one, sorry, I clicked on the wrong thing. But there is a way that you can go through and select a different encoder that is an actual external encoder. And it might be the fact that I have this drive here, that's the problem. But if I wanted to, I know I can do it on this. I can go to here, go to configuration, and if that encoder is external to that drive, then I can just say data connection encoder, then I can go here and I can actually select here. I have my Profinet IO system, and here I have this TM pods input 1, TM pods input 2, and then should be a local module here. Well, I don't think I've compiled the hardware, that's not why it's showing up here, but normally you would be able to find that encoder here in this encoder area for that external. So unfortunately, I didn't prepare enough on it, but that's where you would do it. So those are the different types of options that you have for encoders coming into this sort of system. You have, oh, I see why. It got networked, but it didn't get assigned. So I want interface 1, I want that here. Now it's going to be available. That's my bad. So that is one thing that you do need to know, that now this should be, there you go, MC encoder, there you go, there's that telegram. I didn't have that assigned to the device, or sorry, assigned to the PLC. That said unassigned there. So that was what that was. So you've got, at really bad resolution is going to be a really bad resolution is going to be an analog tachometer, but you only need to use an analog input. It's going to be an analog input based on the speed. Then you have a couple of types of incremental encoders that we talked about. You're going to need to bring that into your system through some sort of device. If you're bringing it straight into your system, it's going to have to be a TM pos input 1. You can also use the encoder telegram. I didn't go into this from like the G120. That is also going to have that telegram information that you could use the memory, and then you can assign things to it. Again, when you use the technology object, all of that is broken out and available to you to use. So if you want to use that position or speed from your technology object, it's connected out to the hardware somehow, but you can use that anywhere in your program. So just another good thing about the technology objects. So you've got the incremental encoders, and then you have the absolute encoders, which you have really two types. You have an NDAT and then an SSI, and both of them require some sort of hardware to come in and interpret those signals, unless you have a Profinet enabled device. Or I guess you could use a Profibus or something like an IO link that's sending it across. But the GSD file would then give you the telegram, so that 81, 82, 83, 84, 860, those telegrams would come across into the memory area and would be available for you to use as a tag. So you could create your own UDTs, you could create your own the PLC data types, and then you would be able to use that anywhere in your system. So hopefully this was useful, and hopefully I would be able to do this more, because yeah, if this works, I should be able to put this stuff out. If you made it this far and you have not liked this video, go ahead and hit like. And obviously, if this is helpful, there's a ton more videos on the channel that are available to you to subscribe. And I mentioned memberships earlier. If you want to support in that way, that really helps the channel out. But liking and subscribing is a free way to support this channel and get this more out there. Hopefully you have a great rest of your week. And if there's any questions about the content of this material, drop a comment and check out the Discord, because asking questions in the Discord, you're not just going to get me, you're going to get access to hundreds of other engineers at different various experience levels. So I appreciate your time and have a good week. Now, get out of here.